In the previous sections, we have spent a fair amount of time discussing how you can figure out what the preferred electrical charge is of different types of atoms. And it turns out that that's relatively easy to do for a lot of the atoms on the extreme left side of the periodic table and on the extreme right side of the periodic table. In the middle of the periodic table, it's a little bit more difficult. There are many metallic elements in the middle of the periodic table. So the way that I would phrase that is that some elements, in particular many metallic elements, break the rules that we've discussed about preferred electrical charges. Another way of saying this is some elements can have more than one type of electrical charge. As an example, iron, which you probably know is a metallic element, iron can either have a charge of +2 or a charge of +3. Depends on the environmental conditions, depends on the situation as to which electrical charge you will find in an iron atom. For those of you who are unfamiliar with iron, the symbol for iron is Fe. Again, this comes from Latin, but the punchline here is that iron can actually prefer to either have a charge of +2 or a charge of +3. So, and if you're only talking about iron atoms that have a charge of +2, the way that you would speak it out loud is you would call it iron 2. That's how you would say it to someone else. Sometimes it's written like this, if you're talking about iron with a charge of +2. Other times it's written like this. It's written, the name of the element is written out, and then in parentheses you put a Roman numeral for however many positive charges that atom has. So for iron 2, we would write iron with the Roman numeral 2, which means this iron that we're talking about has a charge of +2. What do you think this would be called? You can pause and think about this for a second. But in this case, iron with a charge of +3 would be spoken to other people. The way you would describe it is you would call it iron 3 instead of iron 2. And if you wanted to write it out, what you would write is, you would write iron with Roman numeral of 3, just like that, except maybe with a little better handwriting. So if I end up writing iron with Roman numeral 2 in parentheses, you should be able to know that I'm talking about iron with a charge of +2, and I'm not talking about iron with a charge of +3. If I wrote iron with Roman numeral 3, then I'm talking about this type of iron. So here are a couple of questions to help you think about how well you understand this topic. What if I told you that I had a compound, some material that was made of iron 2 and chloride ions, and let's say that you know that chloride prefers to have a charge of -1. What would the chemical formula be? What I'm basically asking here is how many chloride ions would you need to interact with an iron 2 ion in order to neutralize it? And you can pause now and think about that. And the answer to that is that you would need 2 of these. You would need 2 chloride ions to neutralize a single iron 2 molecule, because the iron 2 has a charge of +2 and the chlorine has a charge of -1. So you actually need 2 of these. You need 2 chlorines with a charge of -1, and then the entire total of all of your chlorine atoms here has a total charge of -2. Your iron has a charge of +2, and if you combine 1 iron and 2 chlorines, then they will neutralize each other. Because of that, the chemical formula for iron 2 with chloride is going to be like this. You would write iron, and then you would write the symbol for chlorine, and you would put a subscript with the number 2 here. This subscript over here basically means that there are 2 chlorines attached to a single iron. If there's only one of these, you don't bother to write the number 1 over here. You just leave it alone and leave it by itself here. So this is our first introduction to what a chemical formula is. This is basically saying 1 iron atom attached to 2 chlorine atoms. And the reason we know it's 2 chlorine atoms is because each chlorine has a charge of -1, and each iron has a charge of +2, because we said we're working with iron 2 over here, and so you need to have 2 chlorines to neutralize a single iron atom. What if I told you that instead of iron 2, as was the case in this question, what if we were working with iron 3 and chloride ions? How many chloride ions do you need to neutralize an iron 3 atom? And you can pause here and try to answer this question on your own. But it's very similar to the problem that we just did above. In other words, iron 3 means that we are dealing with iron atoms that have a charge of +3. We already said that chloride ions prefer to have a charge of -1. So we can basically ask how many of these do we need to neutralize one of these. And since each one has a charge of -1, we need 3 of them. We need 2 more chloride ions, so there's all 3. And if you have 3 of these, they will neutralize one single iron 3 atom. And because of that, the formula for iron 3 chloride is going to be iron and then chlorine and a subscript of 3. And again, this 3 here is saying that we have 3 chlorines attached to 1 iron atom. And that's pretty much it. One thing that I should point out is that even though this iron has a charge of +3 and these chlorines over here have a charge of -1, when they're attached to each other in chemistry, it's customary not to actually write out the electrical charges. You can if you want, but in general, people don't do that. So even though this thing does have a charge, you don't write it out when it's attached to something else. Same thing for each of the 3 chlorines. Even though they have a charge of -1, you don't write them out when they're attached to the iron. So I'm going to ask a few more questions that are very similar to the ones that we've just gone over. So here, copper ions can either be copper 1 or copper 2. In other words, copper ions can either have a charge of +1 or a charge of +2. Then here's the question. If I told you that I had some material and the formula was CuCl2, and Cu is the symbol for copper, the formula is CuCl2, what kind of copper ions do I have? Do I have copper 1 ions or do I have copper 2 ions? And you can pause here and I'll discuss the answer in a second. So the answer is basically, it requires us to remember that chlorine or chloride ions prefer to have a charge of -1. And if we look at this formula is telling us that we have 2 chloride ions attached to every single 1 copper ion. So we have chlorine and another chlorine with a negative charge, and they are all attached to 1 copper. Well, what's the charge of all of the chlorines put together here? The total charge is -2. And if these 2 chlorines are going to neutralize this copper, what is the electrical charge of the copper? Well, these 2 have a charge of -2, so the copper has to have a charge of +2. So in this case, the type of copper atom that we're dealing with when we have CuCl2 is this kind of copper. We're dealing with copper 2, and we're not dealing with copper 1. There's a table in your book, table 4.5, I believe it's on page 135 of your book, and it basically lists a bunch of the atoms that have multiple preferred electrical charges. You can look at that table if you want. You certainly don't need to memorize all of the information there. I don't want you to memorize the information there. It would be a little bit of a waste of time. However, if I tell you in a problem that you're working with some material, and I'm just going to call it some pretend atom A, B, C, D with a Roman numeral of 2, you should be able to know what that Roman numeral 2 means. You should know that that means that this atom over here has a charge of +2. And if I tell you that you're working with some other pretend atom, let's call it XYZ3+, you should be able to tell me that that's the same thing as writing XYZ with a Roman numeral of 3. And you should be able to do any of the problems or problems that are similar to the types of problems that we did on the 2 previous slides, no matter what type of element that I give you.